Hey guys, this is Miss Adams. All right, so we're looking at the Units 8 and 9 test review, problem 5. So this problem goes back to lesson 9.1, as well as problems 5, 6, 7, and 8. So problem 5 says state what type of function the graph is, and then determine the AROC, which is the average rate of change, for the given intervals. Then circle if the average rate of change for the function is constant, so the intervals have the same average rate of change, or if it's varying, so they have different average rates of change, so therefore the average rate of change over the whole function is changing. All right, so let's look at the graph. Looking at it, this doesn't look linear, doesn't look quadratic, so this function type is exponential. There's clearly an exponential curve. So now let's find the average rate of change over these two intervals. So from where x equals 0 to where x equals 1, and for when x equals 2 to where x equals 3. Thinking back on average rate of change, this is slope, so it's your rise over run. Rise over run can also be called your change in y divided by your change in x algebraically. I showed you back in lesson 9.1 that slope equals, the equation for slope is m equals y2 minus y1 divided by x2 minus x1. But that's not always the easiest equation for students to remember, so I did show you a different way to solve it using a table. So let's do that today. So let's find the average rate of change for this first interval from where x equals 0 to where x equals 1. Setting up the table, I'm going to have x and y. So I'm looking where x equals 0 and where x equals 1. So let's revert to the graph. Let's look at it and see. So here is where x equals 0. When x is 0, y equals 1. Let's do the same where x equals 1. So if I'm looking at the graph, when x equals 1, y equals 2. So now I have two ordered pairs. I have the pair 0, 1 and the pair 1, 2. Thinking back to the original slope equation, you had these y2s, y1s, x2s, and x1s. That just related them to these values here. I could say that this is x1, this is y1, this is x2, and this is y2. Does it matter which way I number them? No, as long as they stay as ordered pairs. Because of this, I'm going to use these numbers and kind of make a slide here. Because remember, we want the change of y on top, because that's our rise, so how much we go up and down, divided by our change in our run. So that's left to right, that's our change in x, okay? So we're going to find the differences here. What happens is in our numerator, we're going to have 1 minus 2, and that's going to be divided by 0 minus 1. Let's simplify this. 1 minus 2 is going to simplify to negative 1, and 0 minus 1 is also negative 1. Anything divided by itself is just 1. So the average rate of change of the first interval is 1. Let's look at the second interval. So we're looking from where x is 2 to where x is 3. Once again, I'm going to make my chart. I have an xy chart here. I'm finding where x is 2 and where x is 3. Let's go back to our graph. All right, so looking where x is 2, go all the way up on the graph, and y is 4. Do the same thing where x is 3. Wow, that goes up pretty high. That's where y is 8. All right, so we're going to make our little slide here again. That puts our differences of y's on top and the differences of x's on the bottom, or our y's are in the numerator and our x's are in the denominator. So we're going to subtract these values. So I'm going to have 4 minus 8 in the numerator and 2 minus 3 in the denominator. Let's simplify here. So 4 minus 8 is negative 4. 2 minus 3 is negative 1. Negative divided by a negative is a positive, and anything divided by 1 is itself. So this simplifies to a positive 4. Now we have to do some comparisons. The average rate of change for the first interval was 1, and the average rate of change for the second interval was 4. Are these the same? Absolutely not. So the average rate of change for the function then is varying. So it's not the same at every interval. Let's look at another graphing example. So go on to problem 6. This one says state what type of function the graph is, just like the last one did, and then determine the AROC for the given intervals. Then circle if this average rate of change for the function is constant or if it's varying. So looking at this graph, I don't have any curves, so this is a linear function. It makes a line. So once again, let's make our tables here. For the first interval, we're given where x is -1 and where x is 0. Okay, so when x is -1, y is all the way up at 7. And when x is 0, y is at 5. So once again, we're going to make our slide. I'm going to modify it here just a little bit so I have room to write. And we're going to find our differences. So your change in y is going to be in your numerator, and your change in x is going to be in your denominator. So when I write this out, I'm going to have 7 minus 5 divided by -1 minus 0. Simplify this. 7 minus 5 is a +2. -1 minus 0 is a -1. And 2 divided by -1 is -2. So that is our first average rate of change. Let's go to the second interval. So I'm going to make my chart again. So I have 1 and 2 for my x values. So let's find what our y values are for those corresponding x values. So when x equals 1, y is going to equal 3 on the graph. So that's our first ordered pair, 1, 3. And when x equals 2, y is going to equal 1. So just like we have been doing, we're going to extend this out, kind of make a slide, so that our y's wind up on top, x's wind up on bottom, and we're going to find our differences here. So in your numerator, you're going to have 3 minus 1, and in your denominator, you're going to have 1 minus 2. All right, this simplifies to 3 minus 1 is 2, divided by 1 minus 2 is -1, and 2 divided by -1 is a -2. So that is the average rate of change of the second interval. Let's compare these. -2, -2, those are the same, so the average rate of change for this function is constant.